For our beam deflection experiment, we are testing with brass. We have dog bones held together with nuts and bolts on either end. The three weights that we tested are blocks of lead. We originally weighed them in grams, so I'm going to convert them to ounces now to make things easier. The first block that we weighed was 342 grams or 12 ounces. The second block was 325 grams or 11.5 ounces. The third block was 336 grams or 12 ounces. And the hook base holding everything is 220 grams or 7 3/4 ounces. For our first test with 3 dog bones loaded, after the hook base is applied for a total of 7 3/4 ounces, we have 6 thousandths of an inch of total deflection. After the first weight is added for a total of 19 3/4 ounces, we have 19 thousandths of an inch of total deflection. After the second weight is added for a total of 31 1/4 ounces, we have a total deflection of 35 thousandths of an inch. After the third weight is added for a total of 43 1/4 ounces, we have 50 thousandths of an inch of total deflection. For our second test with 2 dog bones loaded, after the hook base is added for a total of 7 3/4 ounces, we have 8 thousandths of an inch of total deflection. After the first weight is added for 19 3/4 ounces total, we have 29 thousandths of an inch of total deflection. After the second weight is added for 31 1/4 ounces total, we have 50 thousandths of an inch of deflection. And for the third weight, for a total of 43 1/4 ounces, we have 77 thousandths of an inch of total deflection. For our third and final test with 1 dog bone loaded, after the hook base is applied for 7 3/4 ounces, we have a total deflection of 21 thousandths of an inch. After the first weight is applied for a total of 19 3/4 ounces, we have a total deflection of 59 thousandths of an inch. After the second weight is added for a total of 31 1/4 ounces, we have 91 thousandths of an inch of total deflection. For the third weight, with a total of 43 1/4 ounces, we have a total deflection of 123 thousandths of an inch. This is a breakdown of all the data that we collected during our experiment. The only test that was fairly accurate was the single dog bone beam deflection, with the percent error ranging from 0.3 to 0.45, which is pretty close to what we predicted based on the beam deflection formula. The 2 and 3 dog bone deflection tests are not as accurate due to the nut and bolt on either side, most likely affecting how much the beam could deflect. Those probably carried some of the load applied. We can't go back and change this now, but we are pretty happy with how accurate our single dog bone test was, and it does show that the more brass you have, the less the beam's going to deflect, as is concurrent with how a realistic brass beam would act in this scenario.